Okay, hello everybody. We are very happy to present our work here today. We will dive right in. Now, the goal of our work was to provide efficient and user-friendly querying of OpenStreetMap data. For example, a query could be give me all university buildings in Freiburg, and the result should then look like this. Now, there are, of course, already several tools available to achieve this goal, and we'll focus on 4 different tools here besides our own work. Command line tools and libraries to parse and filter OpenStreetMap files, the Overpass API, a Postgres database loaded with OpenStreetMap data using just a standard off-the-shelf import script, and the Sophox project, which generates RDF triples from OpenStreetMap data and loads them into a Blazegraph instance to provide a Sparkle backend. Now, our own work is conceptually similar to Sophox. We use our tool OSM2RDF to convert OpenStreetMap data into RDF triples, and these are then loaded into our Sparkle engine Clever, which also provides a convenient user interface for query building. Now, in this table here, we compare these approaches on 4 aspects, namely data completeness, query efficiency, how convenient and powerful the query language is, and interoperability with other data sets. And as you can see, I won't go into details here, but as you can see, none of the existing solutions is really satisfactory. They typically excel in only one aspect, while, at least in our opinion, our work excels in 3 aspects, with the remaining aspect being work in progress. Now, as an example for limited interoperability, consider, for example, the OpenStreetMap format. This here is a snippet of OpenStreetMap XML. In OpenStreetMap, the data is built of nodes, which describe points, ways, describing polylines, and relations, which are just groups of other objects. And it is important to note that only nodes may have specific spatial information. Objects can have arbitrary key-value pairs, for example here, building university, and ways may sometimes be interpreted as polygons, and then they are then called areas. So this way here is actually describing a building at the University of Freiburg. Now, this format is specific to OpenStreetMap and has grown historically, so it is quite hard to combine this with other data sets without writing some sort of glue code. This here is an example of the RDF triples generated by our tool OSM2RDF. The data is now represented as a list of subject-predicate-object statements called triples. And for example, these 3 lines up here describe the same building as the OpenStreetMap data on the slide before. Our tool translates all OpenStreetMap attribute keys into explicit RDF predicates, and it generates explicit shape geometries for each object in the well-known text format as shown here. Now, contrary to the example OpenStreetMap we just saw, the interoperability of RDF is excellent. To combine this with another dataset, you simply have to concatenate the triple files and you're done. Now, as an example for an inconvenient query language, it is enough to look at this example query for the Overpass API, which actually finds all OpenStreetMap relations with identical Wikidata tags. Well, the query language is kind of script-like, but it follows a rather arcane syntax, which is very hard to read and understand. And additionally, as an example for limited performance, this query actually timed out on a dedicated Overpass API instance after 3 minutes. Now let's build a query using our approach together for all university buildings in Freiburg. So this here is the Clever UI, the UI for our Clever Sparkle engine loaded with OpenStreetMap data converted to triples by our tool OSM2RDF. So we start by typing an S, and it already suggests the query body for us. So what we want our buildings to be located in Freiburg im Breisgau, so we can just type this. It should be contained, of course. We are now interested in not in one building, but in many. So we use this placeholder here, which we'll now specify in detail. It should have an OSM key building, and this key should be filled with the value university. And we want the geometry of this query. So it should output the object and the geometry, and we can now execute this query, and it retrieves all the data we wanted in just 7 milliseconds, which is great, and we can actually display this on a map, and this is just exactly what we wanted. So how does this compare performance-wise to other approaches? Well, we formulated these 4 example queries here. And as you can see, our RDF and Clever approach actually compares quite well to the other approaches. So the Overpass API actually timed out for query 1 and query 2. Sophos only also timed out for query 2, and Postgres was very slow for query 1 and query 2. And it's important to note here that Sophos does not retain the complete shape information, but only centroid points. Now, under this URL here, osm2rdf.cs.unifreiburg.de, we actually provide weekly updated TTL extracts from the OpenStreetMap data. So you can download RDF data generated by our tool OSM2RDF here, either for the entire planet, individual continents, or individual countries. You can just select them, download them. They are bzip2 compressed, and use them for your own project. Okay, that's it. Thank you very much.